Hello everyone. Today we will discuss another experiment related to your heat transfer, that is emissivity measuring system. The aim of the experiment goes like this: to determine the emissivity of a grey body. You all know that emissivity is defined as the ratio of emissive power of any body to the emissive power of a black body. And a grey surface is a one wherein the radiative properties, it could be emissive properties or the reflective properties, they remain same for all ranges of wavelength. Now, the observations are like this. We have a brass material which is considered as a grey surface. Then the specimen size is 150 mm in diameter, thickness is 6 mm. The voltmeter is digital type, which can vary from 0 to 300 volts. The ammeter is again a digital type, which can vary from 0 to 3 amps. The total number of thermocouple used are 7, and the heater used is nitron type. Now you can see this is the setup wherein you have a chamber. You have two surfaces. One is considered to be a black surface, another one is a grey surface. We have mounted 3 thermocouple on black surface, T1, T2, T3. T4, T5, T6 are mounted on grey surface. Now you have one more thermocouple which is placed in chamber. Now this basically we can get the emissivity of a grey body using the principle of energy conservation. We will be equating the energy transmitted to the black body. With the help of that, we will be calculating the emissivity of a grey body. We all know the governing equation for radiation is being the Stephan-Boltzmann law. Using that, we will be calculating the amount of heat transfer to the black surface. Equating that with the grey surface, we can easily calculate the emissivity of a grey body. You all know the equation for tabular column for the experiment is as follows. You have serial number, you have heat input, voltage reading, current reading, and V into I, which gives you the heat input. We have 3 thermocouples mounted on black body. So corresponding to black body, we have T1, T2 and T3. Corresponding to grey body, we have 3 thermocouples, T4, T5 and T6. T7 is the chamber temperature as explained earlier. Now you need to take, for a given set of voltmeter reading as well as ammeter reading, all the temperatures corresponding to black body as well as grey body along with the chamber. Now in this case, for both the bodies, you need to set same voltmeter reading, then only we can equate both the heat transfer and we can get the value of emissivity of a grey body. The calculation part is as follows. You need to take the average temperatures of a black surface, which is T1 plus T2 plus T3 upon 3. It should be kept in Kelvin. In your experiment, you will be getting in degree Celsius. Add that with 273. Similarly, for grey surface also, take the average of T5, T6 and T7. Put the value in terms of Kelvin. The ambient temperature, it is TA, which is nothing but the chamber temperature, T7. Now heat input is calculated as I said, V into I. Now the principle of working is, we have assumed the energy to be conserved. Whatever heat supplied over here is supplied to the grey surface. It means the heat supplied to the black body as well as grey body can be equated. Now the mode of heat transfer is the radiation. Corresponding to radiation, we have Stephen-Boltzmann law as sigma emissivity of the black body into surface area Tb to the power 4 minus Ta to the power 4. The same equation for a grey body can be written as sigma, where sigma is the Stephen-Boltzmann constant, emissivity of a grey body, which is to be calculated, surface area pi d into T, we can calculate this, Tg you have calculated over here, Ta is the chamber temperature. Now in this case, we can cancel sigma as well as surface area as they are being constant. Area for black body as well as grey body is kept same. Sigma is a constant, we can cancel both. We left with emissivity of a black body into Tb to the power 4 minus Ta to the power 4, where emissivity of a black body is again 1 because it is the ratio of emissive power of a black body to the emissive power of a black body. The numerator as well as denominator are same, hence we can get emissivity of a black body to be 1. Now in this case, the only unknown is emissivity of a grey body, which can be calculated as Tb to the power 4 minus Ta to the power 4 upon Tg to the power 4 minus Ta to the power 4, where Tb is the average temperature which you have calculated and Tg is the average temperature of the grey body which you have calculated. Emissivity measurement apparatus. So before you begin, make sure the connections are proper. Switch on the mains. Then you need to set the heater values. You have two dimmerstat separated. One is meant for black surface and another is meant for grey surface. You can see there is an indicator which will give you an information corresponding to which heater the value is displayed. Now for our purpose, I have set the voltmeter reading for both the heaters to be 100 volts. Now I have explained you, we will be having two surfaces. One is a black surface and the one is a grey surface. We have mounted 3 thermocouple on black surface and we have mounted 3 thermocouple on grey surface. Underneath the plates, we have heater coil which is made up of nitro. To both the heaters, we are supplying same amount of heat energy. Now that will be ensured by looking at the value of voltmeter reading. Once you are done with the setting of the voltmeter, you need to wait for minimum period of time for attaining stable conditions. Once you attain the stable conditions, you need to take the value of T1, T2, T3, which are the thermocouples mounted on the black surface. Similar for T4, T5 and T6 mounted on the grey surface. Now you can see here, if the pointer is corresponding to 1, that indicates the temperature that is displaying corresponds to T1. If it is towards point 2, this temperature corresponds to thermocouple 2, thermocouple 3 and thermocouple 4. Generally, the temperature on grey surface will be higher than that of the black body because the emissivity of a black body is being more, it emits more energy. Hence, always the temperature on a black surface will be lower than that of the grey surface. You can take 2 or 3 sets of reading. Once you take all the readings for thermocouples mounted on the surfaces along with the chamber, you can calculate the emissivity of a grey surface using the formula that are already discussed with you. Thank you.